This meeting is being recorded.
Yeah, so in yesterday's class, we discussed about like how we build different sets of reachability, right? Like, for example, we discussed how does the routing works, how does the PC of one network, how does it reach with the other network with having a router in place. So to connect between two different subnetworks, and we need a router, right? So a router can connect two different subnetworks, and if we have any connectivity problems, the router will look into its routing table and it will see where the ARC resides for that entry and what is the next hop to reach that. It will go to the destination VLAN, and then the destination VLAN switch will broadcast that packet and that gets the response back. So today let's talk about a topology. Let's take a topology and let's talk about how does the routing is involved, like a static routing first and then the dynamic routing. Let's talk about the differences between them. So let's do the screen share. So let's say this, there is a router one. Router 2. Router 3. Router 4. So let's say the destination IP that we are trying to go is 10.10.10.20. And on the router 3, on the router 2 and router 1. So let's say that the source is trying to go to, this is the source. This is the IPS 10.20.10.10. So here, this is the PC or the server, whatever it is. So on the router 1, to go to the destination, there are two paths. Right, so it can go via R2 and then go to R4 and then go to destination, or it can go to R3 and then go to R4 and then go to destination, right? So here, if you put a static route means manually adding destination routes to the next hop. So as it indicates, we are manually adding the destination route to the next hop, meaning, so we are saying on router 1 to go to this destination IP, route through R2 via this interface. For example, interface is 1 and the interface is 2. So if you want to go to 10.10.10.20 on the routing table, we are manually saying to go to this device. That is a manual configuration. And if this link go down, right, what will happen is there is no failover to this router because it is static. So what we have to do is, if this link go down, we have to manually put another static route pointing to R3. Let's say you are in the middle of night, you are sleeping, and this link went down. For some reason, maybe this someone is passing through this router and then they unidentifically cut the cable. Just for example. So this link went down. Then the router 1 is still pointing to router 2 interface, but this link is not there, so the reachability is not there. The communication will break from source to destination. So in that case, you as administrator has to come online in the midnight and then change the route back to R3 to go back to destination. Is this a feasible solution?
No.
No, this is not a feasible solution because the network has to reconverge by itself. So that's why the dynamic routing protocol exists. So dynamic routing. What does the dynamic routing does here is it will select whichever is the best path. So if let's say it will select R2 as the best path and it will put the R3 as the backup path. If the best path fails, it will automatically inject the backup path. Even though you are sleeping, it will automatically do that for you by validating if the active path fails, automatically the backup path will be injected into the routing table. This can be done using routing protocols like OSPF, EIGRP, IS, RIP, like this, and also IBGP. ISIS is pure DC data center technology. It's not covered in CCNA. OSPF and EIGRP are at the base level, and RIP is already covered. It's no longer used. RIP is like the age-old protocol. IBGP is internal BGP. This is also not much covered in the CCNA syllabus, but we will discuss about that dynamic routing little bit more when we talk about those protocols. But the big difference is static routes are manually added. If a link go down, we have to put a manual next hop to the destination route via other hop. That is the difference between the static routing and dynamic routing. Any questions, guys? No questions? Is it clear?
Yeah.
Okay. Now let's move on to the next thing. Well, before we move on a little bit deeper, let's talk about a protocol called a utility called traceroute. Let's talk about the traceroute. Have you guys heard of traceroute before? So traceroute is source. Let's say this is a Seattle router, a PC in Seattle, let's say. server in Seattle. Let's say this is router in Utah, and then router in Kansas, maybe. Router in Maryland, maybe. Chicago, Virginia, in New York, in New Jersey, and let's do Connecticut, and we just do Massachusetts, and then maybe Rhode Island, and connect your destination. Let's say web server. Maybe Oklahoma, maybe Arkansas, Texas, Atlanta, Florida. So the source is in Seattle. It's trying to reach a web server in Rhode Island, right? So usually when the source sends the packet, it can go. So it can go in any path, right? Doesn't matter. It can go any path, or it can go something like this, like that, right? So there are different ways, different combinations. But what decides the best path is the routing table, right? For example, for the source to go out to the destination, it has only one path, that is Utah path. But for Utah, there is two ways, whether it can go to Kansas or it can go to Arkansas. So there are two paths. So on the router in the Utah, it will look into the routing table of Utah and then select which path has the better metric, meaning which path is more feasible. If you are using OSPF, whichever path has less cost, that path is feasible. If you are using EIGRP, whichever has the less delay, less bandwidth, high bandwidth. If you are using BGP, it will be high local pref. If you are using RIP, shortest distance. If you are using what else? If you are using ISIS, it will be closest level. So these are all different considerations to select the best path, right? So let's say it used a dynamic protocol called OSPF and selected the less cost path. So let's say the cost of Kansas is 100 and the cost of Arkansas is 1000. So because of this link cost, it will choose this path to go, right? So based on that, every router will look into the routing table and select the better path. For example, it can go directly to Maryland, or it can go directly to Chicago, or it can directly go to Atlanta, like that, right? So let's say it went to Chicago, and then Chicago to Florida, and then New York, New Jersey, MA, and then Rhode Island, and then the destination. So we know that this path is selected using the routing table. So the routing table will tell what is the best path to go to the destination on each router. Will this router know what is the best part of this router? No. But this router know what is the best path to go to the destination, whether to go via Kansas or whether to go via Chicago. Obviously, when it has to have a link between them, right? So whichever is the best path will be decided by the routing table. So now we understood this part. But let's say there is a user sitting in Seattle and complaining that my reachability to the web server is not working. Meaning, hey, I am sitting on a PC in Seattle. I'm trying to go to a web server in Rhode Island. For example, he's trying to see www.rhodeisland.com. But when he browses his browser, when he types HTTPS rhodeisland.com, he's getting 404 page not found. When he types this URL, he's getting 404 page not found error. So what, as a network engineer, what is your responsibility is, you have to make sure there is no network drop between the entire path. So as an engineer, you have to make sure that, okay, so I have my path this one. So what I have to make sure is there is no breakage in the path. To make sure there is no breakage in the path, what is we do is we will use a tool called trace route. So trace route will tell you what path your packet is taking to reach the destination. So how does it work? Trace route works on a packet called TTL. TTL value. So when you type in, I mean, I want to show how the trace route works. For example, let me stop share here and then share an actual screen or a terminal window. Let me go there. Okay. So I'm on a terminal. You can do so when I did the trace route, it sent. I'm sorry, give me 1 second. Let me clear that. Let's complete that. Okay. So what I try to do is I'm sitting, this is Kiran, my laptop. I'm trying to go to traceroute google.com. So I'm trying to go to google.com. I want to know what path my packet takes to reach google.com. That is what. So here, this is my first hop. What is this first hop is? This is my Linksys router inside my home. Austin.rr.com is my router full name. My router name, because I live in Austin and I have a provider and they have named it as austin.rr.com. That's their router, right? So that's the PC. I mean my router that's sitting in my home. That's this IP address. So after that, the next hop, if you see, there are 3 asterisks here. When you receive a asterisk means my packet went to the second router, but the second router does not want to tell its name to me. It's filtering and it's not responding to my packet, but I will not stop there. Next time, I will send the packet with the TTL value of 3. So now let's talk about the TTL here. So let me stop share here and then reshare that whiteboard. So here I am in Austin. I want to go to google.com. Same, let's say the same path. So I went to my only router in my home. So when I send my first packet, I sent the TTL value. TTL means time to live. The TTL value of packet is equal to 1. That means I am sending a packet with a TTL value of 1, meaning that packet should live only 1 hop, meaning my packet should die, meaning it should not go multiple hops. For example, the source A, when it sends the first packet of TTL value of 1, it can go only 1 hop away. So the router in my home responding back for that TTL value of 1, what its IP address is. Hey, I got your ICMP message. It uses a protocol called ICMP. So the TTL USL protocol called ICMP, the source will say, hey, I sent you a packet with a TTL value of 1. I'm trying to reach google.com. What is your IP address? The router in my home will respond back saying, hey, here is my IP address. In this case, my IP address is whatever that is getting in the first hop in my trace route. For the next time, I'm going to send a TTL value of 2, meaning I'm sending 1 packet with 2 hops, meaning it can go to router 1 in Utah, and the Utah will look into the routing table, will see, okay, Kansas is my best path. So now I'm going to send to Kansas, and my TTL value will die there because I can only do 2 hops. Now the Kansas will say, hey, my IP address is blah, blah, blah. So now I know the second hop IP address. Similarly, so on and so forth. So there are two ways we can identify the problem if there is a problem in the network, right? So let's say my TTL value, my path failed here. What does that indicates? Means the Chicago does not know how to go to google.com because it does not know how to go to Virginia, or it does not go to how to go to Florida. That's why my packet is dropping at Chicago. I can tell that there is a problem on the Chicago router because I was able to go with multiple hops until Chicago, but after Chicago, my TTL, there is no response back. I think the problem is the Chicago router does not know how to route to google.com, and there is a problem. I have to log into on the router and check the routing table. So based on the trace route, we will know what path the packet takes and where the failure may be. But in few cases, let's say the Chicago router is not blocking the packet, meaning it knows how to go to Virginia and it knows how to go to Florida, but it does not want to tell its IP to me, then it will just show it as asterisk. So in the output, you will just see as asterisk because the Chicago router does not want to show its identity to the source. So if you look back to the terminal, so the first router is the Link 6 router. It's telling its IP address. The second hop does not want to tell its IP address, but it's not blocking the trace route because the next packet is sent it out. So the next one, it's going to something called chatter.com. And next it goes to spectrum.com. And so on and so forth. It goes here. And then looks like there are multiple hops again and again. They don't want to share its IP address. And at 23rd hop, I was able to reach 142.250.138.102, which matches with the destination that I'm trying to go. So in this way, I know whether my network is good or not at the trace route level. If my trace route fails and if I was never able to get to this IP, that means there might be a problem with the network. We have to double check the routing table on whichever route it fails. Is that clear, guys?
So can you please explain about again TTL?
Okay, sure, I can. So I was sitting in my home on my PC and I'm trying to go to google.com. So to know my path, I will use a statement called trace route google.com and on my CMD command prompt or my terminal window. So what am I doing is I'm sending the first packet with a time to live value of 1, meaning my packet can live only one hop away. It cannot send the same packet to the next hop because the TTL value will die. So my packet will send, hey, I want to know the path to google.com and my TTL value is 1. So I will look into my routing table on my PC and okay, I can go via Austin router. So the packet came in Austin router, but the TTL value died here because the TTL value becomes 0 here. Here the TTL value is 1, it became 0 here because the first hop is completed. So it's 1 minus 1, 0. Now the Austin router responds back saying that, okay, here is my IP. So I will see my first hop as Austin IP. So now this indicates that, okay, I can reach to Austin. There is no problem between me and Austin. Now what I'm going to do is I'm going to send the next packet with TTL value of 2. Now the TTL value became 1 here. This is the TTL value is 2 here. It became 1 hop. So the TTL value become 1 and it will go to the next hop until TTL value becomes 0. So now the TTL value becomes 0 here. It stops the packet forwarding again. Now, okay, now the chatter will look into the routing table and then see, okay, here is my IP address to you. So I know the next hop is chatter. Similarly, next the TTL value will be 3.
Okay.
TTL value will become 0 here. it sends its response back. Okay, now the third hop will be spectrum. What if there is no route exists from chatter to spectrum? Then even though if I send the TTL value of 3, it will go to the first hop, second hop, and here it does not know how to route to spectrum. Now the TTL value dies here. It says destination unreachable. That means that, I'm sorry. That means that we know there is a problem between chatter and spectrum. So that is how the trace route will help us to identify the path in the network. If someone says, I have a source IP, I have a destination IP, I don't know what path my packet takes, you can do a trace route and you can see what path the packet is taking inside your network. Let's say you joined in a company, let's say CBS, and you are on your shift. Someone gave you a server IP and saying that, hey, I cannot go to google.com from my server. Do you know what might be the problem? You as a network engineer, you have to do the trace route from his PC or from his network, whatever the VLAN that he is in. You have to make sure there is no issue with devices, routing, and make sure the trace route is working as well to understand the better path. Okay, so that is how we can understand if there is a network problem in the routing or not. Is that clear?
Yeah.
Okay, let's do quick questions. Hari, can you tell me when there are two hops, which hop will be decided a better hop from the router perspective?
I didn't get the question.
When there are two next hops on the router, which hop will be selected as the best hop? I mean, best path.
I mean, whichever is closer to the destination.
Well, closer meaning like what? How does the router know which one will be the closer?
I'm sorry, I don't.
That's fine. Anyone in the class? How does the router know which path to take?
It depends on the
Routing table.
parameters
By-
like
by
cost
checking
and
the routing
everything in routing table. Yeah.
Yeah, so yes. So it checks the routing table to see which path is better.
The best path.
Like for example, if it takes a protocol like IGP, like OSPF, whichever has a less cost.
Less
Like,
cost.
that's how it knows which path will be better. Okay, Ismail Khan, is this your first class? Hi Ismail, you there? Okay, that's fine then. Managna, can you tell me what is the importance of TTL value in trace route?
So depending on the TTL value, it goes to that number of hops and then it returns the IP value so that we can trace a packet at which IP address it stopped or.
So what happens?
To basically to know the path of the packet.
Okay, yeah. So basically to know the path of the packet, you will send incrementing TTL values. But what is the maximum number of TTL value? For example, the source is trying to go to destination, but it keeps on incrementing the TTL value, but there should be a limit in incrementing the TTL value, right? So that the maximum hop is 30 hops, 30. For example, if your source lives in, let's say, New York, and your destination lives in, let's say, Malaysia. From New York to Malaysia, it can send the TTL value of 1, 2, 3, 4, 5, 6. But if your destination lives more than 30 hops away, the trace route will never work because the trace route limit is TTL value of 30. So if you sit anywhere in the world, you can reach the other world part in less than 30 hops. So no, if I sit in US and if I want to reach something in India, it does not take 30 hops. So that's why there is a limit of TTL value of 30. Okay, that's just one. I just want to clarify that as well. If someone asks you like, hey, what is the maximum TTL value? Like how many maximum number of hops your trace route can take? You can say 30. Okay, any questions there before we move on? Okay, this trace route is important because.
I have a question, sir.
Okay, go ahead.
So TTL value is 30. So if we can't reach the destination with excess of TCL value 30, so we choose the shortest part by a trace route.
Trace route does not show the shortest path. The routing table does.
Yeah,
Trace
routing
route,
table.
just look into the routing table to see which path I can take. But trace route does not. Trace route is not a routing protocol to help you to find a better path. Trace route will just use the routing
Identify
table
the path.
to identify the path. That's it.
Okay.
Okay. So now let's move on to a different topic in the routing table. Let's talk about administrative distance. No, before we move on there, let's talk about shortest fixed length. This is before we understand the shortest fixed length. Let's talk about a real world scenario. Okay. Okay, so let's say you are on let's say a person. A person will want to go to this street A. So there are 4 paths he can take. I mean, there are 4 options he has. One is USA option, there is Texas option, there is Austin option, and there is street A option inside Austin. So if you want to tell your address, what you will do is you will tell that inside USA, Texas state, Austin city, go to that street A and that door number within specific person name. So this is the most preferred way. But let's say there is only USA, Texas, Austin. And if a person wants to search for an identity of an address of a person, other person, where will he go in Austin? He knows to go to USA, go to Texas, go to Austin, but he does not know what is the address of the person in Austin, what street, and what is the door number. He does not know that. So which one is better, guys? Knowing the street name and the door number is better, or knowing the city of Austin is better? Which one is better?
Knowing the street name and that.
Yes. Knowing the street name is better because we can identify that person easily. Similarly, when there are 2 or more routes, for example, there is a /32 route and there is a /24 route. There is a /23 route. I mean, let's say /24, and there is a /28 route. So this is like a street address because it's one host. And this is city address. Can anyone tell me how many hosts will be in this /28?
Two power 4.
That will be 16. This is like state address. 256. So the answer of 2 power 4 is 32 minus 28, that is 4, and 2 power 4 is 16. So whenever you have a route of, let's say, 10.10.10/32, that means we are telling a specific address of a device, because this is a /32. This is a more specified prefix length. And let's say there is 10.10.10/28. This is pointing to a route in a group with more size. This is like pointing to the city address with this group size. So with that analogy, which is preferred, guys? Is /32 is preferred or /28 is preferred?
/32.
Yes. So that is called the longest prefix match or shortest prefix length. Both are same, but longest prefix match or shortest prefix length, meaning like whichever route is the shortest prefix length, meaning like only one host, or the longest prefix match, meaning like this person is looking for a dedicated person and there is a match to it. So that is pointing in a route table. If you have multiple routes, whichever route has the longest prefix match, meaning we are matching the right route. That route is preferred than matching a route in the group. That is the routing condition. So in a router, if you have two routes, and if you want to choose one route over the other, the router with the longest prefix match wins. So in many interviews, they will ask, hey, I have a /28 route and a /16 route. Which one is preferred? You have to say the longest prefix match, which is /28 is preferred than /16. So the order of operation is /32 is like the single host entry. Next /31, 30, 29, 28. So it decrements like that, and the preference adds like that. Any questions there? No, is it clear? Okay, let's talk about administrative distance. That will be the last topic for today. AD. AD is the standard value that is dedicated to each protocol by industry. It is called administrative distance. So again, let's talk a real world scenario to understand this. Let's say so there is a source. You are sitting in Austin. You are trying to go to New York. So there are multiple ways to go there. One, you can walk. Two, you can bicycle. Three, you can go car. Four, you can go by bus, or you can go by train. Five, you can fly on the airplane, right? So walking, bicycling, going in a car, going in a train. You can also do a sea route, maybe, right? Going in a ship or traveling in the air, right? There are different options. Which option is better, guys? So flying is better because it saves a lot of time, right? So maybe from a perspective of time, if we chose going through airplane, that is better. So industry thought that, okay, so let's give an AD value of this air is 0. And what is the next better path? Going maybe via car road is better because maybe I can go with the family, I have my private trip, and it's just the mileage cost, maybe like that, right? So the car value on road is 1, the AD value is 1. Next, train, AD value is 2. Next, ship, AD value is 3. Next, bicycle, AD value is 4. Next, walking, AD value is 5. So industry thought that these are the numbers that we define if a person want to go from Austin to New York. So automatically, when a new person comes in, they say is that, hey, the administrative distance to go via airplane is 0, so you choose the airplane path. If the airplane path is not available, let's choose the car path. So industry had defined different levels for different protocols. Similar concept that exists in networking. So you have different protocols like static routing, connected routes, OSPF, EIGRP, IBGP, EBGP. So there are different values, right? So let's talk about those values, what industry defined for those protocols. Connected route. I think I have to type that. Connected routes. Okay, so the connected route values. Next is static. Next is external PGP. Next is EIGRP. Next is OSPF. Next is IS. Yes. Next is accelerate. So industry thought that, okay, if the route is a connected route, let's give the AD value as 0. Static route, the AD value is 1. EPGP, the AD value is 20. EIGRP, the AD value is 90. OSPF, the AD value is 110. ISIS, the AD value is 115. RIP, the AD value is 120. So industry thought that, okay, if there is a route that exists in connected routes, let's put the AD value is 0. Static route 1, like that. So industry defined these routes. So if the packet comes in and this router has connected route to the destination, like let's say source is trying to go to destination of 10.10.10.2. So in the routing table, if there are 2 routes on the source, I mean, if there are these many routes, it can go via this route, this route, this route, this route, this route, this route, this route. It will choose whichever has the lowest AD value. So out of all these, the connected routes will be first preferred route. If that route is failed, next the static route. That fails, next this one, like this, like this. So this is to help network engineers and the routers to know when there are multiple routing protocols in the network, when there are multiple paths and both of them are sending the same prefix, the router can choose one path over the other based on the administrative distance. Again, the longest prefix match will be the first preference, right? As I talked, /32 is more preferred than /28. But let's say there are same /32 routes learning from here and also from here. For example, /32 is learned from connected route and also on the static route. Then there is a tie. There is a tie with the shortest prefix length. Then it will use the AD value to choose whether with the connected route or the static route. So here the connected route AD value is 0. So this path is preferred. Any questions there?
So is this AD value present in the routing table? Like one of the parameters that we are choosing this prefix length, right?
It is in the control plane of the router.
Okay.
Do you know what is a control plane?
No. Can you explain?
Anyone
I
knows what is
forgot.
a control plane? Control plane is like the brain of the system. It's the brain. So on the router brain, it has all these values stored.
Yes.
Yeah. So whenever it sees the route in the routing table, it sees, let me show you, right? So let me log into your router. I'll show you how does the routing table will look like. Give me 1 second. My VPN dropped, so I have to log back into that. Give me 1 second. I'm logging into your router. If I do show IP route, if you see here, C is connected route, S is static route, R is RIP, OSPF, like that. If you see, static route has a AD value of 1. I told you that in our list, the static value will have AD value of 1, so that is mentioned as 1 here. If you see the BGP, it has the eBGP value as 20. So that's why you see the value of 20 here. So automatically when a routing is, for example, this is connected route, it is directly connected. It does not have any value. Similarly, because the value is 0 for the connected routes. Similarly, let's say this is static. This is not the static. This is directly connected. Let's say this. So this is the static route. S is static route. You see the value of 1. So in the routing table, when it's defining the route here with this code, it will automatically point to the AD value, but that it knows from its control plane. Is that making sense now?
Yeah.
Yeah, that's how it knows which path to choose when the, for example, there is a /32 here. It is choosing the directly connected route because the connected value is 0. So that's why it chose that as its best path in the routing table. So whatever the routes you see in the routing table, those are the best paths. Otherwise, that will not install that route in the routing table. Okay.
Okay.
Okay. I think we'll stop it there. I'll let you guys ask any questions on this class. Let me stop the recording. Or hold on. Let me quickly ask a couple of questions on this topic. I'll stop. Hari, can you tell me when there are 2 prefixes, which prefix will be chosen? Is it the longest prefix match or a shortest prefix match?
Longest prefix match.
Yep. So when there are 2 paths, whichever has the best value, whichever has the best match, the longest match, that is preferred. Okay, Monica, can you tell me when there are two protocols, how does the router decide which protocol to use? Monica, can you tell me when there are two protocols?
Yes, sir.
I'm sorry.
Yeah, yes, sir, I'm hearing. Yeah, can you repeat once again, sir?
When there are two routes in two different protocols, which are the same routes, which routing protocol is used by the router?
Based on the routing table and the base path.
Yeah, the paths are same. They both has the best longest prefix match, but how does the router decides which routing protocol to choose?
By using route selection, like route path.
No, anyone?
Based on the AD value.
Yeah, based on the administrative distance. So every protocol will have an AD values, whichever, let's say, Sudhir, which AD value is preferred? AD value 1 or AD value 10?
AD value 1.
Yeah,
So,
AD value
I'm-
1 is preferred. Yeah, AD value 1 is preferred because whichever has the lowest AD value, that path is preferred. So in this case, whichever protocol has the lowest AD value, that path is preferred. Okay, guys, I think that's it. I'll stop the recording and I'll leave the questions. Leave it for questions.